All right, this is section 13.2, the very last example, finally, in this section. We're going to look for the volume of a wedge sliced from the cylinder x squared plus y squared equals 1 by these two planes. Once again, I'm going to see what we can figure out by hand, and then we'll use technology to kind of help us continue to visualize. So I'm going to begin by saying, in the xy plane, that's a circle of radius 1. It would be the cylinder, then, parallel to the z-axis. Like so. All right, these are planes. Both are planes parallel to the y-axis, since y is not mentioned in either equation. So starting with z is equal to 1 minus x. It will have a z-intercept of 1. And notice that z would be 0 when x is 1. So it's going to go through x equals 1, z equals 0 over here. And so I'm going to get this slanted plane like this, slicing through my cylinder. I'm going to end up then with kind of an elongated circle, really an ellipse. Like so, forming the top of my shape. So that's my z equals 1 minus x. The other plane, z equals x minus 1, is going to have a z-intercept at negative 1, so that would be down here. I'm also going to notice that, again, x equals 1 will make z 0, so it's still going to have an x-intercept of 1. So this one's going to have to slant down this way. And then that plane will form the bottom of my shape. And then the cylinder itself is kind of like the sidewall. So again, it's almost like a Pac-Man bite that's been taken out of this cylinder. Oops, that's not even a z equals. That's just an x squared plus y squared equals 1. All right, so let's start by setting up our double integral, and then we'll go back and look for the r. To get the volume, I do need the double integral of that height function. And as always, height is top minus bottom. So top would be this blue plane. That was the 1 minus x. Subtract the bottom, which is the pink plane, x minus 1. All right, let's think about our r. R is going to be the region in the xy plane, and that's really been cut out by the cylinder this time. It's really just this whole circle. X squared plus y squared equals 1. So, if I think of that as being my region R, and it is the whole thing, whether I go top to bottom or left to right isn't really going to matter. I'm going to have to solve this equation for either x or y. Either way, I'll just go ahead and do vertical rectangles again, meaning that I'll want to solve for y. So the top half here is going to end up being the positive square root. Y would be 1 minus x squared, positive square root. And then the bottom will be the negative square root. So if I do dy then dx, y goes from the negative square root of 1 minus x squared to the positive square root of 1 minus x squared. And since my circle has radius 1, the x's will just go from negative 1 to positive 1. All right, let's simplify that just a little bit, and then we'll integrate. Let's see. I'm going to have 1 minus a negative 1, so that'll be 2. Minus x would be a minus 2x. And so integrating, I'm going to say that's all constant with respect to y. So 2 minus 2x times y, evaluated from y equals the negative square root to y equals the positive square root. So I have 2 minus 2x times the square root of 1 minus x squared, subtract 2 minus 2x times the negative square root of 1 minus x squared. In fact, those two negatives can, of course, just be used to make that a plus. So I really have two copies of the same thing. I could pull the 2 out here just to make my typing into the calculator a little easier, and just say I have 2 of those terms. And when I did that integral on the calculator, I ended up with about 6.283. And I got a little suspicious seeing that number and double-checked, and in fact it did turn out to be exactly 2 pi for the value of that integral. I didn't go back and show you, but just real quick to look at and kind of confirm our picture here. If I did look at GeoGebra, notice here's my cylinder and my 2 planes. You can kind of see that 2 planes slicing through and creating that wedge out of the cylinder as we expected. And then the same thing can be seen on Maple. All right, finally, that is the end of section 13.2.